Willebrord-Snellius's law is the formula which describes the relationship between the angle of incidence and the angle of refraction of a wave passing from one medium to another. The refractive index of light is the ratio of the phase velocity in the reference material, the vacuum, and the phase velocity of the medium under test. The velocity of light in water is 3/4 the velocity of light in a vacuum, and for glass it is 2/3 the velocity of light in a vacuum. The refractive index of air is 1.008. For water it is 1.333. For plexi it is 1.5. And for crown glass it is 1.52. Christian Huygens postulated that the change in phase velocity is caused by the electron charges in the material oscillating slightly out of phase with the driving wave entering the medium. As a result, the electrons radiate their own wave fronts. It is the sum of these new wave fronts which results in a wave of the same frequency as the original wave, but of shorter wavelength. This results in the reduction of the wave velocity. This is not the same type of oscillation found in gas discharge or semiconductor light sources. These light sources produce line, band, or monochromatic spectra. In gas discharge and semiconductor sources, electrons oscillate, resonating between higher and lower electron orbits. The electromagnetic energy released when the electron returns to the original stable orbit is inversely proportional to the emitted wavelength. The refractive index of an optical material is dependent on the wavelength of the light. The refractive index decreases with increase in wavelength. It is this mechanism which enables a prism to display all wavelengths in white light. This mechanism of refraction also causes chromatic aberration in lenses.